This is Mod 2.4 Investigating Symmetry. This is the precursor for the idea of proportionality and congruency that we're going to see all year. So let's get started. Symmetry is basically a rigid motion that exists that maps the figure onto itself. A figure has line symmetry, okay, or reflectional symmetry. So again, we're doing with that idea with reflections. If a reflection maps the figure onto itself, each of these lines of reflection is called a line of symmetry. So this is a line of symmetry. If I was to fold or reflect the other half of this moon, okay, or toenail, over that line of reflection, or line of symmetry, I'm sorry, it'll map onto itself perfectly, okay? Now, you saw the GIF here. If you drew a line and you were able to map it out, you would have a line of symmetry as well. That's how you were able to rotate it and still spell symmetry. Okay, so that was just a little visual for you at the beginning. All right, patty paper. So basically, trace this figure on a piece of tracing paper. I'll tell you what, you can always just draw like a 3-inch sided here, 3-inch here, and 1-inch here. Okay, on your patty paper. And basically, you're going to have an isosceles triangle where you have two equal sides. Also, by the way, there are two angles down here would also be the same. So go ahead and create that on a piece of paper, piece of patty paper. All right, like so. Now what you're going to do is you should already see, well, if I fold here along this dotted line, um, it should map onto itself. Okay, it should be able to trace one half and fold it onto the other half. This is a line of symmetry. So this figure ultimately only has one line of symmetry. If you were to try to fold it any other way, you would not be able to map it on to itself. So therefore, you only have one line of symmetry. Again, line of symmetry is right here. All right, let's see some more examples. So we're going to draw lines of symmetry, and we're going to determine how many numbers of lines of symmetry each figure has. So if I was to fold this rectangle here, that would be one line of symmetry. If I was to fold here, that would be a second line of symmetry. So it looks like we only have two there. You could try any others and see if you can find more. If not, well, okay, but at least you tried. Now it looks like I'm going to assume this is an isosceles triangle again. So isosceles, usually, there you go. Only has one place where we can fold it. So one line of symmetry. I like to number my lines just to make sure I don't count them twice. For this next object, oops, that's a little off. I only see one. Okay. So if you were to fold here, it would map onto itself. So again, I only see one line of symmetry there. It's wherever you can fold to where it maps onto itself. All right, now we have lines, now we have rotational symmetry. So rotational symmetry, basically a figure has rotational symmetry if the rotation maps the figure onto itself. So instead of folding, we're rotating. So if you look at the star that's below here, it's going to rotate around this point of rotation. If it rotates 72 degrees counterclockwise, it'll map onto itself. It'll be itself, okay? The only difference is this pointy end turns to this pointy end. So let me explain. This pointy end turns to this pointy end, but it'll still map on, it'll still look like the same star, just rotated 72 degrees. That's what they're talking about. So this is an angle rotational symmetry. Basically, you rotate it 72 degrees and you're all set. It looks just like what it was. Now, I want you to know um, angles of rotational symmetry have to be between 0 and less than or equal to 180. So again, greater 0 or greater at less than 180. Now, if they tell you to list all the rotations of symmetry, then you're thinking about 0 to 360, and we'll get to that. All right, example 3. So if I was to determine the rotational symmetry of each object, notice how they're going to say rotation less than 360. That's because they're talking about angles. So let me explain that. If I was to rotate this object, no, first things first, let's count how many lines of symmetry they have. I count 1 there. I count 2 here. And if I was to fold here, that would work also. So that's 3. And if I was to draw a line here, that would work too. That would fold and map onto itself. So that is 4. So I have 4 lines of symmetry. Now, the trick with this is basically you have 360 degrees, okay, a full circle, divided by the number of lines of symmetry. So if I was to rotate, or if I was to try this triangle here, or I'm sorry, not triangle, silly me, the square, you have 360 degrees divided by 4 lines of symmetry. Thank you, touchscreen, for doing what you just did. And you should get 90 degrees. Now this is actually considered our rotation, our angle of rotation, okay? But they're saying angles of rotation. So if I rotate it 90, it'll work. If I rotate it another 90, it would still work, okay, which would be 180. And another 90 still would work, and 360. It would still map onto itself. Don't believe me? Try it with patty paper. You could always see it. All right, isosceles, again, only have 1 line of symmetry. That means you can only rotate this guy 360 degrees only to where it maps onto himself, okay? Now, this one tries to get tricky here, but if I fold it there with a line of symmetry, that'll work. And if I fold it, sorry, this is a terrible line. There you go. If I fold it this way, that'll give me 2 lines of symmetry. So again, 360 degrees divided by the number of lines of symmetry, and you should get 180 degrees. Now, angles of rotational symmetry, basically you have 180. If you, oops, sorry. Don't know why I'm apologizing, because that is literally just the technology. All right, so you can turn it 180 degrees, that would work, or another 180 degrees, which is really just 360. So those would be your angles of rotation that's less than 360. Oh, less than. So I guess we could kind of ignore the 360. It says less than. Okay, so that's something to note. Less than. All right, example 4. Describe the lines of symmetry of each figure. Draw lines of symmetry. Name the angles of rotation, or both if the figure has both. So looking at this object, if I was to fold here, that looks like it would map onto itself. So that's a line of symmetry. So that's 1. If I was to fold here, terrible line, I know, that would work. And lastly, thanks, whatever that was. And if I was to fold here, that would be my 3rd line of symmetry. So it looks like we only have 3 lines of symmetry. Now angles, again, angles, that's plural. If you didn't rotate it at all, that would also work, actually. It's kind of a little joke. If you rotate it once, well, let's see, we got 3 lines of symmetry. So remember, 360 degrees out of the number of lines of symmetry. So we have 120 degrees. So 120 degrees would be our first spin. Another 120 would give us 240. And lastly, 360 would be our another 120. So these are all the angles of symmetry that we can have, angles of rotation, okay? All right, your turn number 4. So basically the same thing as my other examples. You have to find the types of symmetry. So again, do we have lines of symmetry? Do we have rotations? Both, none, either, maybe one of them. So try to figure out what they have. And give me the number of lines of symmetry if they have them, and give me the angles of rotation if they have them. Notice it says angles again, so we're talking about all the angles. So remember 360 and number of lines, and that'll get you the angle of rotation, and then you just keep going until you get to 360. So you might have to list them out. All right, your turn number 2. Same situation. Types of symmetry. If they have both lines and rotation, or just one of them, or neither, give me the number of lines of symmetry and the number of angles of rotation. Same deal, same deal. So get some practice. All right, so describe the types of symmetry for each figure, draw lines of symmetry. Same type of deal. See if you have lines. If you don't, you don't. If you have angles of rotation, if you don't, you don't. So try to work with your group and see where you can fold to where it maps onto itself, and then just see where you guys get with that. All right, guys, have a great night and a great day. And if you have any questions, let me know.